Hey guys, in this tutorial we'll be making a multiplayer Pong game. Let's start by creating the UI for which our players can connect to our game. So I'm going to create a 2D scene. I'm going to name this Network Manager. I'm going to add a child node of control. I'm going to add a panel node. I'll spell that right to our child, and I'm going to center it and make it big and nice like so. I'm now going to add a VBox container so that everything will align vertically, and I'm going to just stretch it to about the size of our panel. I'm going to add a child node, HBox container, which will align things horizontally. And I'm going to align it at the center. I'm also going to align the VBox container at the center as well. I'm going to add a child node to this, and I'm going to just add a label. And I'm going to just call my label multiplayer Pong. And so I'm just going to change my HBox container to say title. My label, I'm going to just go to theme overrides, font sizes, and I'm just going to increase the font to something that looks more like a title, so much bigger text like that. I'm now going to duplicate my title, and I'm going to call this IP. And I'm going to make my label say IP label. So we need to get the player's IP so that you can connect to the game. So I'm going to change our label text to just say IP address. And I'm going to shrink the font size so that it's less annoying. I'm going to add another child node to this HBox container, and I'm going to just give it a text edit. I'm going to rename this to IP text. Now I'm going to say our text box default text to be 127.0.0.1. So this is an IP address, and it's what you'll use to connect to a server. This is every computer's local IP address. So this is essentially just something so you can connect to yourself. This will not work for other users over the internet. For that, you'll have to port forward, and I'll have some links to resources on how to do that in the description. Now we can go and change our layout so that, it's not so small. So I'm going to increase our minimum X size to not 500, but 200 maybe? And I'm going to increase our Y to 30. That looks good. I'm going to duplicate this again. And now I'm going to delete the label in text. And I'm going to rename this buttons. I'm going to add a child node, and I'm just going to get a button. And I'm going to have this button's text say connect. And so I'm going to name this connect button. And I'm going to duplicate this, name this host button, and change the text to say host. Not connect host, but host. There we go. Perfect. So when you click these buttons, it'll essentially connect will just connect to a server, host will host the server on your computer and allow users to connect to it. Now let's program players being able to connect to our game, shall we? Let's go up to our network manager scene and attach a script. I'm going to keep this network manager and I'm going to make it C#. I'm going to get rid of any defaults for it since we won't be using a lot of those. And create. So now I'm going to have to define a couple variables. So first variable is going to be the port. So const int port equals something like 25565, which I think is Minecraft's default port. So the port is essentially a hole through your firewall, which you'll have to create if you want other people to connect to you over the internet. So the next variable is going to be a text edit. So export text edit, and I'm going to call this IP text. And the final variable for now, we'll define more later, is export control and I'm just going to call this UI. So now if we go back into our Godot and build the scene and save our scene, I guess, I'm going to call this, Network Manager. Now we can assign our IP text. So our text edit here. And we can assign our control to the UI. Perfect. Now let's connect our buttons to the script so that our people can actually join and host servers. So I'm going to go here to the host button and go into Node and going to click the press signal and connect it to our network manager script. I'm going to copy this and click connect. So back in our script, I'm going to create a private void and I'm going to paste in that string I copied earlier. Now let's define a variable, enet multiplayer peer. I'm just going to call this peer equals new enet multiplayer peer. And so this is essentially the variable we'll be using to create our server, and we'll have to define this in our connect button to create our client as well. And so now we can just do peer.createServer and hand in our port that we defined up here. Now we could do some error checking to make sure the peer actually connected. So if peer.getConnectionStatus equals multiplayer peer dot connection status dot disconnected, what are we going to do? I'm just going to gd.print and say server creation failed. And then I don't want to run this code anymore, so I'm just going to hit return. So if our server creation is successful, now we need to set our multiplayer peer equals our current peer that we created. This is essentially passing our peer off for the Godot to handle. All right, now let's do this again for the connection button. So we can go back into our game and click connection button and connect the signal to our script again. So I'm going to copy our variable or our function name and click connect and create another private void. Paste our function name in. Now we're going to have to do a bunch of these steps again. So enet multiplayer peer equals new enet multiplayer peer. Peer.createClient this time. This time we'll be passing in the IP address we took in from our UI. So I'm going to do IP text and then passing our port. I'm going to copy our error detection here, paste it, and just instead of server creation failed, client connection failed for our error message. Once again, hand this off to Godot to handle multiplayer peer equals peer. Now let's create a function for both our client and our server to call once they've connected and hosted the game. So I'm going to do another private void, start game, and I'm going to pass in a parameter of an ID. So this will be used for authority later, which I'll explain. And all we're going to do with this right now is do UI.hide. So now on our server, we can call start game. And we can pass in multiplayer.getUniqueID to it. And so what the unique ID is it's a random value given to our players once they connect to the server. However, if you are the server on the server, this unique ID will always be 1. This is a way of identifying which players are which in a very simple way so that players aren't controlling each other's characters. So I'm going to copy this and paste it onto the client side as well. Finally, we're going to want to replicate our start game function on the server when the client connects. Because if the client connects and starts spawning things, essentially it's going to be a security risk and someone's going to ruin everyone's game. So we can go up to our server and do peer.peer connected. So when a peer connects, run start game. Perfect. So now if we go into Godot and run our game, and I'm going to select our current scene as the main scene, and I forgot something. If we can go into debug and we can run multiple instances. So for this game, since Pong has 2 players, I'm going to run 2 instances. So now if we run our game, it'll pop up 2 windows. So on this window, I'm going to click host and our UI will disappear. In this window, I'll click connect. So you see no errors are popping up in our error log. So perfect. You've now created a basic multiplayer server for users to connect to. Now let's create a player for people to control. So I'm going to close these and create a new scene. And I'm going to click other node and give it a character body 2D. And I'm just going to rename this to player. I'm going to add a child node and I'm going to give it a sprite 2D. And I'm going to pass in the default Godot icon for this, since I don't really have other graphics on hand. And I'm going to make it look like a Pong paddle. So I'm just going to decrease the size here. Now I'm going to add a child node and give it a collision shape 2D. Going to give it a rectangle shape and drag it to about the parameters that look about accurate for our Pong paddle. I'm going to save our scene and I'm going to call it player. Now, this next step is very important. We need to add another child scene and I need to add a multiplayer synchronizer. This is how the server will tell things like position. So if I can go down here into our replication and add a property to sync, and I'm going to click our root node player. Now I can look up position. So this will sync the position across the network. So I'm going to save our scene again. And now let's spawn our player. So back into our network manager and back into our network manager script. In our start game UI, or actually, here I'm going to define one more variable, export, hacked scene. And I'm just going to call this player scene. So save this, go back into Godot and build. Now I get to drag our player scene directly into our network manager. Now back into our script. Here in start game, let's spawn our player. Let's instantiate our player. Character body 2D, temp player equals player scene dot instantiate, and I'm going to say instantiate as a character body 2D. Now this next step is very important. So if you remember up here where I said giving a unique ID is going to tell our server which player is which, well here is where we're going to give it that data. So I'm going to say temp player dot name equals ID dot toString. So ID is what we passed in right here. And we'll use this later to give authority, which essentially is saying, again, who owns what. Now I'm going to want to spawn our player into the center of the screen. So I'm going to just do temp player dot position equals get viewport dot get visible rect dot size divided by 2. So this will spawn it right in the center of the screen. Now, since our network manager is our root node in the scene, we can just do add child temp player. Perfect. So if we go back into our network manager scene, and since we're done with control, I'm going to minimize this here. We need to add one more thing to our network manager to actually allow us to spawn our player. So I'm going to add a child node, and right here, we can add a child node of a multiplayer spawner. So we need to select our spawn path, which is going to be the root node of our scene, so the network manager. And now we're going to create an auto spawn list. So I'm going to add an element here, and I'm just going to drag in our player that we created. And I'm going to save this. So now if we run our game again, and I'm going to host, and you'll see it created our first player, and I'm going to connect over here. I think the players are just on top of each other, so this is our way of synchronizing creation of players. So I'm going to close this now, and let's give our player some logic. Let's give it some movement logic. So in our player script scene, I'm going to add a script, and I'm going to call it player.cs, and I'm going to inherit nothing again. So first thing we're going to do is set our authority. So we're going to tell our player who owns this object. So we can do public override void enter tree. So when our player enters the scene, enter tree. I'm going to keep this base tree just in case. We're going to set multiplayer authority. We can just do int32 dot name. Oh, int32 dot parse and pass in our name. So this will set our authority. Now let's add some startup logic. So public override void underscore ready. It always does that. Ready. There we go. Gonna just delete this. So now we're gonna check if it has multiplayer authority. So if not is multiplayer authority, return. So if you do not own this object, you cannot run anything in the ready function. Now, since we only have 2 players, I'm going to check if it's the server. So if multiplayer dot is server, what are we going to do? Well, we're going to set our position to each side of the screen for the server and the client. So position equals new vector 2. And I'm going to set this 50 units away from the side of the screen. And get viewport dot get visible rect dot size dot y divided by 2. And I forgot our brackets here. So now I'm going to do an else. So if we're the client, position equals new vector 2. We're going to keep it in the center of the screen. But now I'm going to copy this, paste it here, make this the viewport size.x minus 50. So now it'll be equal distance away from each side of the screen. So now if we go back into Godot and run our game again, and we host, it'll appear on one, and we connect, and there, it'll appear on both sides of the screen. So now let's go and add some movement to our players. Back into our script, let's create a public override process. So run on every frame. We don't need the base process. So once again, if not is multiplayer authority, return. If you do not own the object, this is very important. If you do not own the object, you cannot control it. Now let's add some basic logic. If input.isActionPressed, I'm going to say UI up. So I'm just using the default controls for now. And I'm going to create a vector2. I forgot to do that. Vector2 vel equals vector2.0. And it added system.numeric, so I'm going to delete that reference. vel.y equals -1, so up on the y-axis, times by a speed variable, which we'll create. And might as well do that here. So I'm going to do export speed equals float speed equals 200F. Perfect. Now we could do else if input.isActionPressed UI down vel.y equals 1 times by speed. So go down on the y-axis. Now we're going to just set our velocity equals vel and call move in slide so it actually moves every frame. Perfect. So you might be wondering why this code looks so similar basically to a basic controller. Like realistically, the only check we do is if multiplayer is the owner of the object. The reason we do that is because of this multiplayer synchronizer we did here. It's going to handle all the calculations for a position, which is very nice that Godot does that for us. It saves a lot of work. So we can run our game again. And I'm going to just put it on both sides. Host, connect, perfect. And you can see, now I can move up and down. And you're going to be able to see it on each screen. So this is working perfectly. But this isn't really a game yet, and we want to add a ball. So let's create a ball for our Pong game. So let's create a new scene. I'm going to make this a rigid body 2D. I'm going to add a child, and I'm going to add a sprite 2D to it. And once again, pass in our default texture that Godot gives us. And I'm going to change our transform. And let's set our scale to like 0.3, 0.1. Let's make our ball small. And add our collision shape 2D and another rectangle. It's a bit too big for us, so let's just... Yeah, that looks good. Let's save it as... I'm going to actually just name it up here as ball. And let's save our scene as ball.tscn. Perfect. So now I don't want our ball to slow down or drop when it spawns into the scene, so I'm going to set its gravity scale to 0. And I'm going to set its linear damp mode to replace. So no damp while it moves. No damping, so it won't slow down through the scene. Now, if you remember on our player, we had this multiplayer synchronizer, and we're going to have to do this again. So add child node, multiplayer sync, not spawner, multiplayer synchronizer, and add a property to sync. We're going to add the ball, and once again, just the position will do. Save our scene. Now, let's add some logic to our network manager to spawn the ball. So let's go back into our network manager script. And I'm going to create a new function, or the process function, public override, process. And I'm just going to create a little private bool has ball spawned equals false or equals false. Yeah, that'll work. So now we're only going to want to spawn this ball if we're the server. So in the process, we're going to check every frame. If multiplayer dot is server, if we aren't the server, so that's what this exclamation point here is. If we're not the server, what are we going to do? We're going to return. We don't want the client spawning anything on the server. So now we need to check. If both clients are connected, we're going to start the game. So if multiplayer.getPeers, so how many people are connected to the server, .length is equal to or greater than equal to 1. So be aware computers count from 0, so this means 2. And has ball not spawned. So if this is true, if the has ball spawned is true, we're not going to run this, so we're not going to spawn a million balls in the center of the screen. So I forgot to get reference to our ball. So export packed scene, ball scene, and let's go into Godot, build again, and we'll just drag our ball scene into here. Perfect. Save our scene, back into the script. So this is going to look very familiar to when we spawned our player. Rigid body 2D, new ball equals ball scene dot instantiate, and it's going to just be a rigid body 2D again. Now let's set our new ball into the center of the screen. So new ball dot position equals, and I'm just going to go down here, copy this, get viewport, get visible rect size divided by 2, and paste it into here. We want it to spawn right in the center of the screen. And once again, we can just add child, new ball. So this should work. So once both players are connected, we're going to instantiate our new ball, put it in the center of the screen, and then add it to the server again. So you might be thinking that there's probably a better way to do this, and you're probably right, but like this is not the most efficient way, but it's a way that works. So we're going to go back into our scene and run our game again. So I'm going to click host and connect. I forgot to do a few things here. First off, I forgot to add it to our multiplayer spawner so it's not appearing on our client. And I forgot to set it has ball spawn to true when we spawned our ball. So let's go do that right now. Multiplayer spawner, add element, add our ball scene, save that, go here, and has ball spawned equals true. Let's run that again. And this time it should work. Host, connect. There we go. The ball's spawned, but it's not doing anything because we haven't programmed any logic to the ball yet. So let's do that right now. Let's go into our ball, attach a script, ball.cs will work. I'm going to keep it empty and create. Now this is going to be a very simple script. Public override void underscore ready. It always removes the R. I don't know why. If it's not the server, so when we spawned our ball, return. So when we spawned our ball over here, if you noticed, we didn't assign any authority. If you don't assign any authority just automatically goes to the server, so the server has control over anything that isn't assigned automatically. So if it's not the server, return. We don't want this logic being able to run on the client. Now we're going to set our linear velocity. Linear velocity equals new vector 2. Let's just set it to 1, times by speed. Or let's just do 200. Okay, so after some testing, linear velocity is not the best way to do this, so I'm going to do set axis velocity to the new vector 2. 1, times by negative 200. That should be good. Now let's test our game, because I was getting some errors before. Host, connect, there. So if you notice some glitching there, it's because the replication isn't perfect, and essentially we need to interpolate to make movement feel perfect on the server. So I think that's fine for now. So now let's actually make our ball be able to bounce off things. So in our ball scene, let's add a physics material. Let's go into it and make our friction 0 and our bounce 1, so it'll have equal bounce. Maybe we can make it 2 to make it double the speed every time it bounces off something. Now we can go into our network manager and we can add things like walls around our scene. for it to bounce off of so that it doesn't just fly off into oblivion. So let's add child node. I'm going to add a static body 2D. I'm going to add a collision shape 2D and another rectangle. That looks good. So I'm just going to drag this across the scene and I'm going to duplicate it and drag this down to the bottom. Now our ball shouldn't jump off the screen. Okay, let's add a scoring system. So I'm going to add in a new control here. And we're going to call this scoreboard. And I'm going to add a child node, and I'm going to give it a label. And let's put the label somewhere like here. And let's just give our label the text of 0. Good default text. And let's do our theme overrides fonts, and let's increase it, font size, and let's increase it so that it looks pretty good. So font size of 50, perfect. Duplicate our label, drag it over here to the other player's side of the screen. I'm going to do player 1's score, label, and player 2 score, label, label. Perfect. So let's add some colliders on both sides of the screen so that when our ball collides with it, it'll give points over to whichever player, has that side of the screen. So I'm going to add a child node. I'm going to add an area 2D. And I'm going to add another child node, collision shape 2D. Let's give it a rectangle shape again. We're going to use a ton of rectangles, and let's just drag it to its side of the screen. We're going to call this player 1 score collider. Perfect. And duplicate that. Just player 2 score collider. Now for player 2, we're just going to drag this to the other side of the screen. Not do that. Gonna zoom in and drag. Perfect. Save it. And we need to add a script to our collider. So attach a script, and I'm just going to call this scorekeeper because we're going to be reusing the script on both. And I'm going to grab export, label, scoreboard. How do I spell board? I don't know. So we're going to be able to drag that in, and let's connect a signal to it. Signal to our script. So on body entered, body 2D, let's connect that to our script and copy the body entered code. So now we can add it in, private void, paste that in, node 2D, and I'm just going to call it node. So if node.name equals ball, which I believe is what we called our ball. Let's just double check it in Godot. Yeah, ball with a capital B. Perfect. So if it's the ball, what are we going to do? Well, we're going to have to update our scoreboard. So I'm just going to add an int score counter equals 0. And we're going to increment this by 1. So score counter plus plus. Let's change our scoreboard. So scoreboard dot text equals score counter dot toString. And let's run our project. You might notice an issue here. So let's host, connect. Let's let the ball go off screen. Let's actually assign the score board that we need to. Let's run that again. Host, connect. So tell me the issue here. See, it only runs on one. So we don't have a multiplayer synchronizer for this. And for when we don't have that, we need to do RPCs. RPCs is essentially sending a direct message to the server to say, communicate with the client. So we can create another function here. Private void, or actually, yeah, private void, update score, and we're going to pass in int score, int new score. Let's give it a different name. And so now here we can do scoreboard.text equals score counter dot toString. New score dot toString. But how is this going to run on all the clients? Well, there's this handy little thing called an RPC, which is essentially saying send a message to all the clients from the server. And so we're going to want to make sure it gets to all the peers. So we're going to do multiplayer API.rpc mode dot any peer. So essentially this is saying give it any peer, will send it to any client on the server. Disabled will send it to no one. So we'll do any peer for this. So now to call the function, we can't just call it like any other function. So like we can't just do update score and then pass in our score counter. We actually have to do something a bit different. We need to use the RPC function to call our function. So RPC update score and now comma score counter. So now let's go and run our game. And now the score should be replicated on both the client and the server. See? Now it works. So now we need to do that again for the other side. So here we can just drag and drop our script. Attach our body entered. Connect. Do not need to change anything in there. And set, just refresh this, our scoreboard to player 2 score. So now if we run our game, host, connect, let's boop. So now if it goes onto this side of the screen, let's dodge it here. It'll set. So if you notice, it'll set the score to 1. So if you notice, the ball doesn't spawn again. So let's allow the ball to spawn again. So let's go back into our scorekeeper script and say no duck queue free. So let's delete our ball. After we delete our ball, we can go into our network manager and set our ball spawned to public. And now we're just going to access that. I know it's cheating, but I'm going to do it this way. For just this project, gettree.root.getNode, network manager, and let's get it from our node name, which is network manager, and dot has ball spawned equals false. So this should be called every time we delete our ball, every time we score a goal. So let's host and connect, and we should have a finished Pong game. Again, if you notice the jittering here, that's because perfect. Well, thank you. I hope you like this tutorial. Please like and subscribe if you want more tutorials like this in the future. Thanks, guys.